Hello, calculus fans. Okay, so let's go rewrite our evaluation theorem. Instead of using a little f, we'll just plug in a big F prime. When we evaluate the integral from a to b of big F prime, we just get big F of b minus big F of a. That's really what the evaluation theorem is saying, but we've just rewritten the way we're plugging in the functions. Now remember that big F prime represents the rate of change of y equals f of x with respect to x. And then f of b minus f of a is the total change in y when x changes from a to b. So let's rephrase our evaluation theorem. So instead of the way that we've discussed the evaluation theorem, we'll say this thing. This is the net change theorem, and it says that the integral of a rate of change is the net change. So the integral of a rate of change is the change. So that's another way of phrasing that the integral of a derivative gets you back to where you started. This is the connection that the evaluation theorem makes between derivatives and integrals and shows that they are inverse processes of each other. Now, we can use this concept and apply it to the rates of change that we talked about previously. And one of the more common ones that we discussed is velocity, and then velocity, position, acceleration, all of those. So this is telling us that if v of t is the velocity of an object at time t, then the displacement of the object between the time t equals a and time t equals b is calculated with an integral. It's this integral, where we can say that the displacement is equal to the integral from a to b of v of t dt. There's one more thing that we can do with this. We can actually say that absolute value of v of t tells you the speed of the object, so we can calculate distance traveled with an integral also. So the distance traveled is the integral from a to b of the absolute value of v of t dt. Let's see, there's a subtle difference. We have displacement, which is calculated with an integral of v, distance traveled, which is calculated with an integral of the absolute value of v. Okay, that's all for now.